Okay, this is the SNES Flash board Rev C by RetroCircuits.com. I know the website isn't working yet, but you can email me at retrocircuits@gmail.com if you're interested in any of this. Okay, so this is a flash card that I have been making. And the whole idea behind this flash card is to make something very versatile and also very easy. Some of the parts on the board, is specifically for the pick and place machines. So, like for example, if you're going to use the non-volatile data, memory, similar to SRAM, it's called FRAM. Then you would have the pick and place machines only put parts on like not R17 and R16. Those would be the only, in that whole section, those would be the only two resistors you'd put there, and they'd be 0 ohm resistors. And so if you're using FRAM, then you would use U10. You would not populate the R15 because you need U10, the NAND chip, to operate the FRAM. But if you're using traditional SRAM, then you would not populate. Well, you could populate U10 because SRAM will work with U10 also. But if you want to save 20 cents on the part, then you could just do the R15 bypass for SRAM, for static RAM. But you would also need to put all these other parts on, D2, D1, R8, R6, Q1, R5, R7, etc. So the versatility of this board, where it can use FRAM or SRAM, if you want to save some pennies, you can kind of choose your configuration. Or, you could just populate all 4 chips, and all the data retention chips too, because FRAM and SRAM will work with all those parts in place. And so I have a LED up here. Let me switch to a different board here. So, like for example, I have an LED on this one, and it just turns on when it's in high map mode. And so, not necessary for any use, just an indicator. And so I'll go through some different builds and just talk about them for a minute. For example, this is a high map, minimal parts, needed. And so, you have your CIC chip there. I have the U10 bypass. And then I have the decoder, U4, the 139 decoder. And then the MUX that kind of determines if it's high map or low map and where it sends stuff. But since I don't have the low map decoder, it's high map only. And so in high map only, these are basically the minimum parts you would need. You would need to populate, the data retention parts, the U10 bypass, these 2 chips here, your ROM, of course, and then this is a 64K SRAM, and 64K would only need R12 populated. And so, and of course, you need a battery to retain the data. And so I'm just going to kind of talk about these in general real quick. These are all, 29F 032, 033, ROMs. But if you notice, it says like low profile ROM 2, and then the other one, the other ROM chip says, high profile ROM 1. I'll talk about that more here in a minute. And so anyway, so I showed you this one here. You know, this is high only. You know, so you only need 2 chips for a high map game. You know, you need the decoder, and really you probably don't even need the mux, but you could actually bypass that, and I'll talk about that in a minute. So so here, for example, is a 2 megabyte ROM cart that is, again, there's no data retention, you know, so there's no SRAM, so you don't need any of these resistors populated. You don't need, you know, any of this populated because that's all for data retention. You know, you need the CIC chip, of course. You don't need any of these. Now, if you notice, there's a HLNP and an HNP. So what that stands for is high or low, no parts, meaning you don't populate any of these parts. And then the HNP means high only, no parts. So I built this as a low map cart, and the so there's a couple of jumpers on the back that you would do, or just one, excuse me. So this is enabling you ROM 2. Okay, so we're going to send the enable signal to ROM 2, and then only if you had a 4 megabyte ROM would you click or solder this SL. And so, but since it's a 2 megabyte ROM, you know, I didn't need to do that. And so I'll show you the. You know, so this is punch out. Some games, you know, look for SRAM and won't turn on, like Mario All Stars. But this one didn't. So okay, so so that was a low mapping, and the reason why it says, you know, high map profile and low map profile is that if you have a 4 megabyte ROM, it doesn't matter. You know which side, just because of the addressing differences between high mapping and low mapping. But you know, if you're going to run something smaller than a 4 megabyte ROM, then you want to mount the ROM. You know, if you're making a high map game, you do it there. If you're making a low map game, you do it on ROM 2. And so, because the addressing, you know, how it's wired is different. And so if you're going to use a, you know, 1 megabyte or 2 megabyte or 1 or 2 megabyte ROM, then you would want to put it on the appropriate spot. So high map profile, the addressing is linear. So if you have a high map game and it's on ROM 1, you can use 1 megabyte, 2 megabyte, 4 megabyte ROMs. But if you were to want to run a low map game, then you could only do 4 megabyte on the ROM 1 spot, regardless of how big or small the actual ROM image is. But in the low map profile, you can use various sizes of ROMs because of how it's pinned, you know. And so, and I'll try and show you the schematic on that in a little bit, kind of explain that for those who don't know. So like, for example, here's a high map, no parts build. And again, you bridge those 2 parts where it's indicated. You mount your ROM. you know, and that's pretty much it. On the back of this, you know, there's nothing bridged or jumpered or cut for that matter. So I use Donkey Kong 3 as my kind of just my test ROM. Donkey Kong 3 saves, but it still starts up without the you know, save data. So I'm just using it for just example purposes. So my desk is extremely messy. So anyways, the Rev C board has a battery where you lots of battery choices. You can put these little flat batteries on the back. You can put regular batteries, you know, on the front that just, you know, go through and solder. Or you can use a battery holder, you know, surface mount or through hole. So I wanted to give lots of battery mounting preferences or choices. Obviously, you know, the surface mount battery holder could be, you know, put on with a pick and place machine. Really, the only thing that probably wouldn't be pick and place would be the dip switch, which I'll talk about that in a minute. So this is kind of a full build except for the NAND chip, which we don't need because I'm running SRAM. So the SRAM, really the SRAM is the one that needs all the variety, all the choices. I mean, this is kind of where things get, you know, complex because there's multiple sizes of SRAMs, physically and electronically. And for example, you know, this board here, you know, shows a 32 pin profile. And these smaller, let's see if I can get this to focus. You know, these smaller pins, you know, 1 and 2 and 32 and 31, you know, the shorter ones. You know, those would be for the 32 pin parts. So I, for example, you know, I've got this SRAM here. This one is a 2 megabyte CY62138. So that's the 2 megabyte SRAM, low power. And so, you know, it occupies all 32. And because it's 2 megabytes, you could even do 4 megabytes. But because it's 2 megabytes, I need all these resistors to drive the address lines that aren't, you know, electrically connected, you know, to the address bus. So in a, I don't know, the vast majority of SNES games that do save use 64K, you know, RAM chips. And so, and then there's a small number of ones that use 256K. And so by default, this board is 64K. And then depending on, like, if you cut, you know, if you do these cuts, you know, where it says cut to limit, you know, SRAM to 16K, because there are games that are 16K and they'll error out if it sees more, like Donkey Kong Country, for example. But there are just a couple of games that use 512 and 1 megabyte. Both of them are low map games. And so in the rare occasion you need that much SRAM memory, you could, you know, bridge those. And so there are some Super Mario hacks that also want that much memory, SRAM memory. So, and then 256K, you know, whether it's low or high, you would solder bridge one side or the other to get there. And then, of course, if you want to disable the RAM altogether, in other words, you have all the RAM parts, you know, on the board. but you need to disable it. Then you can just cut or cut that one right there. And so this one here is Chrono Trigger Crimson Echoes. So this is an extended high map game. So it needs two ROM chips, and because there's no save parts up here, you know, U10 is populated because the SRAM is here. So really, all these resistors are not needed. Only R12 would be needed in this example. Actually, R12 wouldn't even be needed because SRAM doesn't use chip enabled number 2. So, but you do need the decoder, the ROMs, and so on. And so, let's see here. So these are set up on where you can use a dip switch, where you can kind of select, you know, what you're wanting for options. And again, the first two is high and low mapping, and then number 2 is SRAM or RAM enable or disable. And then after that, the next two, 64K or 16K. So if you do the cuts on the back, then the dip switch, you know, takes over on, you know, what your options are. And so, and then the last 4 is 256K high or low, depending on, you know. So only one of those would be, or only 2 of the 4 would be used. And so, for example, you know, this board has 64K RAM, and so I wouldn't need, you know, a dip switch, you know, for this side because it's native 64K, and that's only 256K selections. And so, let's see here. Where was the other one? So like this one, for example, Crimson Echoes, you know, it only has 2 dip switches because, you know, mapping and RAM enable or disable. And even then, you know, only 1 dip switch would have been, you know, fine because, you know, I'm not going to disable RAM on Crimson Echoes. But in my testing, let's see here, did this. You know, in my testing, though, you know, I could program something different on there, and, you know, something that may, like the Mortal Kombat or Doom, you know, where they have the expanded versions of those. So this is Chrono Trigger Crimson Echoes, and you can see that you know, I have a save. Whoops, come on. Yeah, so you know, I got the prologue. You know, so this is, you know, the prologue was saved. You know, doesn't have a battery. You know, so it's all in the SRAM. So, okay, let's see, where am I? So here's kind of a rare example of, I guess, something you could do. Because it has 2 ROMs, and the way the SRAM is controlled, the SRAM being 1 megabyte or bigger, might be even 2 megabyte or bigger, but yeah, 2 megabyte. So you'd have to have a 2 megabyte ROM. Let's see here. Yeah, so A17, the MUX will toggle that one high and low. So let me show you, for example. So this board has Super Mario on it, or All Stars. And you can see that, you know, it has a save file there. But if I switch it to high map and Donkey Kong is 16K only. Come on. You know, so, you know, and you can see the save there as well. So it's really not meant to be a multi-game board, but, you know, with this arrangement, you know, you could put two games, but it would have to be, you know, ROM 1 high, and the second ROM would have to be a low map game, because it's just the way it is. Okay, so so let's talk about the schematic for a minute. So even though this, let's see here. So even though this shows like two parts, these are actually on the PCB, they're merged into one part. So that RAM can be really 4 megabytes or down. It can even be 16K RAM if you bridge. R12, because R12 would be SRAM A13. A13 would be pin 24, which would be the power pin of a 16. So like here's this 16K. So you know, so you could use RAM anywhere from 16K all the way up to 4 megabytes, or 4 megabits, excuse me. And so you know, the versatility of this board, you know, is apparent. And then you can see the SLs here, you know, SL3 and SL4. That's for the, you know, getting the 512 and 1 megabyte, you know, RAMs in a low map configuration. So anyway, and so you need resistors, you know, if you're going to use anything higher than a 256, you're going to need, you know, these resistors right here. And so R11 you would only mount R11 if you know, had ambitions to disable the RAM. Otherwise, you know, you could leave that off. And again, R12 is SRAM A13, but on a 64K ROM, pin 26 SRAM A13 is chip enabled number 2, which means you have to pull that line high for the RAM to activate. Otherwise, it would just turn off. So on a 64K, it's CE2. And so that's why it's pulled high. But if you mount a 256K SRAM, then pulling that high a little bit, you know, because that would be A13. It would be actual A13. So, you know, pulling that high, you know, is no big deal. And so, all right, so up here, so these are the ROMs. So ROM number 2, you know, you've got the low map profile, which means A16 through A21 go to, certain parts of the ROM. If you notice this little notation here, it says A22 low, A15 high. So that one, so the MUX, the MUX, the 257, right here. So this is the clean my lens here. So the MUX is the it switches, for high and low depending on what's what. And oh man, this is getting bad, isn't it? So this is the output, A15X ROM, and so the choices are A22 or A15. So A15 would be linear, which would be high mapping, A15 going to, ROM A15. But in low mapping, A22 is the other, is the highest address. And so you'd want that to go to the ROM. And so that's essentially why ROM 1 has a high map profile, and ROM 2 has the low map profile, because those are pinned differently. So these are pinned differently because if you're going to program these ROMs by hand, with your EEPROM programmer, and mount them by hand, then you would want them, if you're building a low map game, then you'd want to put it in the low map position. If you're using a programming device like I built here, then it doesn't matter. The addressing absolutely does not matter. It just needs to be connected to a address. So this one, this is my SNES programmer, and then this switch right here, if I need to force it to a low map or a high map, then I can slide that switch over. Otherwise, it just stays in the off position. And the programmer can determine what mapping the cart is just by, it can auto detect. But on games like this, where there's no chips, then you kind of have to tell the programmer, hey, I am going to program in a low map mode because you can't tell the difference between high map and low map without the chips, being on that cart. And so, but anyway, so the programmer, can dump, it can erase, it can write. It's all USB connected. So you just get a little window, up on the, up on the screen. So you put that in. It just opens up a window. And so this one here, it's I've forced it to be in low map mode. Green is low. So it says low up here, which is what you want. So I can take this, and I can delete it or and then write something else there. And then it has SRAM. And let's see, this is off the screen, isn't it? So, yeah, so it's going to assume SRAM is 64K, even though there's no SRAM chip there. It would just be, 0. This is just primarily so you can just drag this and dump your SRAM contents. You can't write SRAM contents, but you can dump it. And so if you had 256K, on there, then it would say 256 and dump that. So, but kind of by default, the programmer is going to assume that your SRAM is 64K, and then it will read the chip size. And so, so you can even go and and do properties and and it'll tell you that there's 0 available, and but if I erase it, then it'll show 4 megabytes available. So anyways, let's see, is there anything else in the schematic? So, let's see. Anyway, so, yeah, so like, for example, I talked about the U10 bypass, U10 bypass, R15, so that just makes it so that this chip is not necessary. And then, these are your save data parts. So anyways, but this is just, now this, obviously uses the, let's see, these are your high map, decoder chips here, and then this is the MUX, and then, okay, so I'm kind of getting lost here, but, so anyways, I'm just, trying to make this as versatile as possible and as easy as possible, for someone to, buy the board. And, golly, why isn't my focus working? That's really bad for some reason. Anyways, I'm going to make this board available on Pcbway.com, where you can order it under their shared projects. Golly, really bad. And so, I don't know why this isn't focusing. This is very bizarre. But, wow, that's bad. All right, well, I'm at the end of my video anyways, and the only real drawback to this is the ROMs, the 29F032 ROMs. They're very difficult to come by. You can't buy them anymore, not in bulk anyways. I made this board because I bought about 2,000 of these ROMs several years ago. So I got about 2,000 of them, still in their sealed packages, and so when I get this board run, at the fab house, get them produced, I'll mail them the ROMs, so they can put them on. And so this board here was really primarily just, I've got all these ROMs, I might as well do something with them, and so making this. Making this board is a good way of doing that. So the last thing I'll mention is that on the extended map games, for whatever reason, my programmer isn't programming the second ROM correctly, and so we have to kind of we have to deal with that issue by hand, by programming ROM 1 and then doing a couple of jumpers and then programming ROM 2. So so that's kind of annoying, but we're hoping to get the firmware fixed, so it'll just program on both at the same time, when you have 2 ROMs mounted. But again, 2 ROMs mounted, I mean, that's such a rare occasion. I mean, the most normal configuration of this board will, if you have SRAM, that will be this. If you're using SRAM like this one is, this will be your most common configuration, where this is high or low mapping 4 megabytes. Or if you have if you're using SRAM instead of SRAM, then this would be the second most, well, not that one. This would be your second most typical you know, configuration would be, you know, this setup. And so, again, a lot of the parts mounted, you know, is just dealing with the, you know, save data chip, you know, the SRAM. If you're not saving data at all, you know, then you could, you know, do this. I mean, you could put the mux there, you know, and it would still do exactly. Well, not really, because how it triggers the low map ROM enable is a little different, but for high mapping, you could just put the mux there. So, anyways, but that's about it. Again, in the next week, 2 weeks, I'll put full schematic, full build up on Pcbway and their shared products. And if I'm not feeling lazy, I'll provide a link in the video for that. And so, but that's it. It's again, I don't mind sharing this board. It's just you know, if you are going to manufacture this board, all I ask is that you don't make any alterations to the board. You know, give credit where credit is due. You know, if you make these, give me a shout out. I would appreciate it.